previous video, I advise you to do so that you can understand what I will be talking about in this video. And also, if you have not yet subscribed, please subscribe and turn on the notification bell on so that you do not miss any of my videos. So if you remember from the previous video, we talked about a linear regression, where we talked about we were hired as a machine learning engineer to create a model which would predict house prices based on the size of houses in feet squared. So, and then later on in the video, we then came up with a hypothesis. So if you still remember, we came up with a hypothesis, which our hypothesis takes in a value of x and as parameters theta 0 and theta 1x. So our hypothesis takes in the values of x and then makes predictions based on the values of x. So in this case, the value of x was the size of the house, which was in feet squared. So in this video, I am going to show you how the parameters of the hypothesis, how the parameters of the hypothesis affect how we best fit our line into our dataset. So if you still remember, this is the hypothesis, where we have the parameter theta 0 and theta 1. So in this case, we have the parameter theta 0 and theta 1. So let's take, for example, let's say theta 1 is equal to 0 and then theta 0 is equal to 2. So we want to visualize how our line would look like. So here on the x-axis, the x-axis takes in the values of x, and then the y-axis is h theta of x. So we want to plot a graph of h theta of x against x. So let's say here it's 1, here is 2, so in this case, let's start with when x is equal to 1. So when x is equal to 0. So in this case, we know that our value of theta 2 of theta 1 is 0. So this whole value is 0 since theta 1 is 0. So when x is equal to 0, in this case, h theta of x will be equal to 2. So h theta of x will be equal to 2. And then let's say when x is equal to 1, so if you substitute here, when x is equal to 1, then h theta of x is equal to 2 when x is equal to 1. So, and then when x is equal to 2, when x is equal to 2, you also find that h theta of x is equal to 2. So h theta of x is equal to 2. And then in this case, our hypothesis would look like this. So this is how our hypothesis looks like when the value of theta 0 is equal to 2 and the value of theta 1 is equal to 0. So let's take a look at the other scenario. So let's say we know that our hypothesis h theta of x, our hypothesis h theta of x is equal to theta 0 plus theta 1 x. So let's say in this case theta 0 is equal to 0, and then theta 1 is equal to, let's say theta 1 is equal to 1.5 in this case. So let's then draw So this is x. This takes in the values of x, and then the y-axis. The y-axis is going to take in the value of h theta. This will be h theta of x here. So let's then put in the values on the axis. So in this case, let's start with when x is equals to 0. So when x is equals to 0, that means that our hypothesis h theta of x is also equal to 0. So it's also equal to 0. But when x is equals to 1, h theta of x is equals to 1.5. So 1.5 is somewhere around here. So when x is equals to 2, if you substitute 2 here, if you substitute the value of x with 2, multiply 2 by 1.5, that's going to give you a value of 3. So you know that 3 is going to be somewhere here. So in this case our hypothesis would I'm sorry about that. So here, and then this is 1.5 here, somewhere here, and then 2 and 3 somewhere here. So in this case our hypothesis would look somewhere like this. Oh, I'm sorry about my drawing, but the hypothesis would look somewhere like this, and it would pass through the point 2 and 3, 1 and 1.5, and 0 and 0. So in this case the hypothesis would look like h theta of x. This is our hypothesis, plus theta 1 x. So by the previous two examples I've drawn here, I wanted to just show you how I just wanted to show you how the values of theta 0 and theta 1 affects how we fit our line to our data set. So in linear regression, to come out with values of theta, we want to come out with values of theta 0 and theta 1 that best fits our data set. So we want to choose the values of theta 0 and theta 1 that best fits our data set. So I'm just going to draw an example. So if you are familiar with linear algebra in high school, you knew that we used to draw in high school. Used to draw a linear regression or something like this. If you have a line something like this, and then let's say your line passes through, I'm sorry about that. So let's say if our line passes through here, and then we know these are the, let's say these are the actual values. So let's say this is our hypothesis, h theta of x. So this is our hypothesis, h theta of x, theta 0 plus theta 1 of x. So let's say this line is what our hypothesis is predicting, and then we know that these are the actual values of y. Let's say this is y1, y2, and then y3. So to calculate the error made by our hypothesis, in this case, So to calculate the error made by our hypothesis in this case, so this is the error made by our hypothesis in this case, we subtract, let's say if it's y2, we subtract y2 from there. Sorry, we subtract y2. This is y2. Oh, I'm sorry about that. In this case, we subtract y2. In this case, we subtract y2 from what the hypothesis predicted. From what the hypothesis predicted, h theta of x. So that's how we calculate the error. If you still remember in linear algebra, so that's how we calculate the error. And also the same applies here. We subtract y3 from what our hypothesis predicted, which is h theta of x. So that's how we calculate the error. So this leads us to what we call the cost function. So this leads us to what we call the cost function in the cost function for. So let's say you are a driver and then you are drinking and driving. So if you are drinking and driving and then you are stopped by the police, and then they ask you to breathe onto a breathalyzer, and then they discover that you have a certain percentage of alcohol, there are high chances that the police is going to penalize you for doing that. So that's what happens with linear regression. So we want to penalize our model when it's making incorrect predictions. So we want to penalize our model so that it makes correct predictions. So in this case we want to in this case we are solving a minimization problem. So we want to minimize. So theta 0 and theta 1. We want to minimize theta 0 and theta 1. We want to minimize the difference between what our hypothesis is predicting, h theta of x. So we want to minimize the difference between what our model is predicting and the actual value. So we want to minimize the difference between the hypothesis and the actual value of y. So what we do here, we minimize this and then we square it, and then we want to find the summation, the sum of this. We want to minimize the sum of this from I is equals to 1 up to m. So if you remember from the previous video when we talked about the notation for linear regression, we said that m was the number of our training size. So in this case it's going to be h of I minus y of I. So remember that I represents the ith training set. So this represents the ith training set. Let's say if we have values of x and y, let's say we say 1, 2, and then say 3, 4. These are the values of x and y. So x1, so in this case x1 is going to be 1, and then y1 is going to be 3, which represent the ith training set. In this case I is 1, so that's why I substituted 1 in this case. So now back to our cost function. So back to our cost function, I said that the goal was to minimize the difference between our hypothesis and the actual value of y. That's the goal. That's our goal. So here, and then we divide it by 1 over 2m, where m is the size of the training set. It's the size of the. So this summation sign means that we are just going to sum all the values of h theta and yi. So this summation means, let's say I'm just going to explain to you, so if you don't understand what this summation means, it's just an addition. Let's say if you say y is equal to the sum from I is equals to 1 up to 4 of 2x. So what the summation does is, let's say it's y is equals to if we substitute 1 here, it's going to be 2. And then let's say when I is equals to 2, then it's going to be 4. When I is equals to 3, then it's going to be 6. When I is equals to 4, then it's going to be 8. So what this means is that we are going to sum from I is equals to 1 up to when I is equals to 4. So this is the maximum when I is equals to 4. And then the total summation in this case is going to be 6, 12, 20. So y is equals to 20. That's the total summation. So this is what this summation sign represents. So this cost function is represented by j. So in this case, it's going to be j theta 0 and theta 1. So the cost function is a function that takes in the values of theta 1, theta 0, and theta 1, and it's going to find the suitable values of theta 0 and theta 1 which best fits our dataset. So that's what this cost function does. So it's going to minimize. So it's a minimization problem, since we are going to we are minimizing the distance between the predicted value and the actual value. So theta 0, theta 1 over 2m. Then we are going to sum from I is equals to 1 up to m from h theta of x I minus y I squared. So that's what the cost function does. So in this video, I just wanted to show you how the values of how the parameters of the hypothesis theta 0 and theta 1 affects how we best fit our data set, and how we can use the cost function to penalize our model. So in this video, I just wanted to introduce you to the cost function. So in the next video, I'm going to go deeper into the cost function, and I'm going to introduce you to another concept called the gradient descent, which we use to find the values of theta 0, and theta 1, where the difference between our predicted value and the actual value is minimum. So thanks for watching, guys. I hope you enjoyed the video. So if you find this video useful, please subscribe and turn on the notification bell on, so that you do not miss any of my videos. And also, you can share this video with all your friends. Thank you very much.